Welcome to the optical communication course. We study here a numerical on the optical communication. Now we see here, consider a multimode step index fiber. Consider a multimode step index fiber with a 62.5 micrometer micrometer core diameter and a core cladding index difference core cladding index difference of 1.5%. If the core refractive index if the core refractive index if the core refractive index is 1.480, estimate estimate the normalized frequency estimate the normalized frequency of the fiber and the total number and the total number of modes supported in the fiber supported in the fiber at supported in the fiber at a wavelength of 850 nanometer. Now here it is about a multi-mode strip index fiber and it has a 62.5 micrometer of a core diameter. Okay, 62.5 micrometer of a core diameter. Now the diameter means what? Core diameter is given for the given particular fiber. Our aim is about to find out the A. A is equal to what? D by 2. That is nothing but what? A 31.25 micrometer. Okay, that A is equal to what? 31.25 micrometer. Now it means what? This one is given, diameter is given, but our aim is about to find out the A, core diameter. Our aim is to find out A. Then a core cladding index difference is given, that is about del is equal to 1.5%. Is equal to 1.5%. That 1.5% is equal to what? Point of 0.015. Okay, 0.015. Means del instead of percentage we can write in terms of a number, that is about a 0.015. Next, here the given is what? If the co-refractive index difference, that is N1, okay, N1 is given, that N1 is equal to what? 1.480. Okay, 1.480. Estimate the normalized frequency. Estimate the normalized frequency means what? We need to find out what is the value of V. V is equal to what? And the total number of mode supported in the fiber means yeah. Our aim is about to find out the estimate the normalized frequency and the number of modes supported in the fiber at a 850 nanometer of a wavelength. Is lambda. This one is nothing but a lambda. So V is equal to what? V is equal to what? Twice by A divided by lambda into N1 under root of twice of del. Okay. V is equal to twice by A by lambda into N1 under root of twice of del. So if you put all the values twice, this one is about a pi we have. A is equal to what? 31.25 micrometer. Okay. Divided by lambda is equal to what? 850 nanometer into N1 is equal to 1.480 under root of twice of del. Twice into 2 into twice means what? Point of 0.015. 2 into point 0.015. Then we'll get that a V number. After solving this, micrometer means what? 10 to the power minus 6. And this is about a nano means what? 10 to the power minus 9. Solid V is equal to, you will get 59.2. That is about a, we can say, a difference that normalized frequency value. Then a total number of modes, okay, the total number of modes supported by the what fiber? Multi-mode fiber. Because the given is here, consider the multi-mode strip index fiber. For the multi-mode strip index fiber, okay, for the multi-mode strip index fiber, so in that case, M will be M is equal to V square by 2. M is equal to V square by 2. So V we know that 59.2 and then we'll get that 1752. Means 1752 modes are supported by this multi-mode strip index fiber. Okay. M means what? That is about a number of modes supported by this particular fiber. That is about a 1752. Okay. That is about a 1752. Now we can consider here the case if we change, okay, if we change this particular parameter, the del, suppose in this particular example here the del is given is about 1.5. If the del is changes, if the value of a del is changes with respect to suppose instead of 1.5, if it is a 2.5 suppose, then all the values will be changes. Okay, means everything is depending upon that. If for any fiber, what will be the size of that n1 and what will be the size of that particular core of a fiber as well as the n1 and n2, then we can obtain that what will be the V number here. Then next in okay, we just vary all these values of a or a del, so you will get the means different values there. Okay, so I'll just proceed with a one more numerical with uh, similar values of what we can say that uh, that is about similar values here. We can consider there, and I will conclude something. Next numerical, suppose we have a multimode strip index fiber. We have a multimode strip index fiber that has a core radius of 25 micrometer, a core index difference, a core index difference, a core index difference del is equal to 0.01 and and a core index, core and cladding. Okay, this one is about a core and cladding, and a core index is about a 1.48. Then what are the number of modes? What are the number of modes in the fiber? In the fiber, what are the number of modes in the fiber at wavelength wavelength 860, then 1310 and 1550 nanometer. Now these three different frequencies are given. Now here, this one is about, you can say lambda 1, lambda 2, lambda 3. That three different wavelength. And that core radius is about 25 micrometer is given. Del is about 0.01 is given. And core index is about n1. That is about n1 is given. Okay, this is about n1. So now the formula is same. To obtain the m, we need to consider the v here first. V is equal to what? Twice pi a by lambda n1 under root of twice of del. And then m is equal to v square by 2. Now all the parameters are same, only there is variation in the lambda. Okay, only there is a variation in the lambda. In the first case, if we consider that lambda is equal to 860. Okay, if in the first case, if you consider that a lambda is equal to 860. So in that case, after putting all the values, we'll get that v is equal to 38.2. So similarly for 38.2, m will be v square by 2. Okay, m will be v square by 2, and that will be m is equal to 729. Okay, m will be nothing but what? 729. That is about number of modes. Okay, that's about a number of modes for 860 nanometer of wavelength. Then in a second case, then we have the second case there. So in that case, we say that operating frequency is of what? 1310, okay, nanometer. 1310 nanometer. Now for this 1310 nanometer, that V will be what? If we put all the values there, A, lambda, okay, everything, N1, del. So then we need to consider that V, okay, that V will be what? Will be a 25.1 and M is equal to V square by 2, that is about a 315. If you consider the different wavelength, that is about a 1550 nanometer wavelength. Then V will be what? 21.2 and M is equal to 224. Only there is a variation in the wavelength. Everything is same. Only there is variation in the wavelength. Then the number of modes, here is about, if you see that, the number of modes are changes here. Okay, if you see here, only there is variation in this. For 860 nanometer, 729. For 1310, modes will be 315. For 1550 nanometer, modes will be a 224. Means it that modes are again depending upon that wavelength. As we have seen earlier, as I told you earlier, it is depending upon that factor of the del or factor of the A. That is about the radius of the given particular fiber. Okay, so that is about, we can say we have seen a optical fibers that are about, we can say optical fiber that a this one we can say a step index fiber. But in the case of a gradient index fiber, so that gradient index fiber, that index is depending on that number of modes. Here we have seen that Vm is equal to V square by 2. But in the case of a gradient index fiber, m is depending upon that. refractive index profile. Alpha by alpha plus 2 into what we can say by v square by 2. That alpha is, we can consider that a refractive index profile. Okay, that alpha is nothing but what? A refractive index profile. Refractive index profile. If supposed to be, if you solve everything for the, so instead of step index fiber, suppose I am saying it is about a grid. So then in that case, alpha is to be there. Okay, then in that case, alpha is to be there. And then we can find. Suppose in, for the same example, suppose I am going to be consider this about the same example now. We have obtained that m is equal to 729. Suppose we consider the same example, and right now I am saying that a alpha is equal to, suppose alpha value is equal to 2 now. Okay, profile, alpha profile will be 2. So in that case, m will be what? 2 by 2 plus 2 into v. V is supposed to be 38.8. Okay, suppose we consider 38.2 divided by 2. So in that case, what? 38.2 by 4. Okay, that will be nothing but your m value. Means m value, that m means what? Number of modes. Number of modes are depending upon that for which fiber we have, whether it is a step index fiber. Okay, this alpha is equal to 2 means what? That profile will be a parabolic. So alpha can be 3, alpha can be a 1. Okay, likewise. So alpha value will be vary. So if it is alpha is equal to 1, then it will be a triangular in a profile. So that modes, this equation is for the graded index fiber and this equation is for the step index. So ms, that is for the step index fiber, mg, that is for the graded. And that number of modes are depending upon that what will be the profile in the graded index fiber, and here it is depending upon that. Okay, they were wavelength, your radius, okay, all the factor. But in the any graded fiber, we need to know what will be the index, profile index. Okay, so that is about, we